Let's look at current. And current is the rate of charge flow. So in current we give a little I to denote that, and we have here rate of charge flow. So we have charge over time. So we have Q over delta T. So this gives us I equals Q over delta T. Q is in coulombs, which is C, and then we have delta T, which is in seconds. So for units of current, we have coulombs over seconds, and we call it ampere, call it A, or call it amps. Now let's look at resistors in a circuit. So for resistors, so this is a wire, and then we have this little squiggly line, continuation of the wire. So we call it R for resistors. So if we put this in a circuit, so we have a wire, and this is a battery. So this is a thicker line and a longer, thinner line. And the thicker line is the negative side of the battery, and the thin, longer line is the positive side. And then we have a resistor. We can have a resistor or two resistors, or how many you want. And we can call this R1, R2, etc. So this is a very simple circuit with two resistors and a battery. Now let's look at connecting resistors in series. Resistors in series. So in series, we have the same current going through all the resistors. So let's just draw a battery. One resistor, second resistor, have third resistor, R1, R2, R3, and this is the battery, so we have a voltage, let's call it V total. So in resistors in series, all the resistors have the same current. So there's some current going through the positive side, let's call it I or I1. So R1 also has I1, R2 has I1, and R3 has I1. So you can think of this as water flowing through a pipe. If let's say the current is 5 gallons, R1 gets 5 gallons, R2 gets 5 gallons, and R3 gets 5 gallons because they are in the same pipe with no branching whatsoever. So all the current that goes through the battery must go through R1, R2, and R3. However, if we are looking at the potential difference, so the V, it's not the same if they are in series. What we have is a V1, we have a V2, and a V3. And V total here is equal to V1 plus V2 plus V3. Also, if we are looking at the equivalent resistance, so if we were to take out all three resistors and just put one other resistor in, a fourth resistor, but has the same equivalent resistance of R1, R2, and R3 combined in series, that fourth resistor must have R1 plus R2 plus R3. So if R1 was 1, R2, let's say R1 was 1 ohms, R2 was 2 ohms, and R3 was 3 ohms, then Req would be 1 plus 2 plus 3, it would be 6 ohms. So let's look at the next one, which is resistors in parallel. So if I were to draw another circuit, say we have R1 here, R2, then R3. So we have a V total. We have a R1, R2, and R3. When I say in parallel, they do not have to be visually parallel. So you see that R2 and R3 are not visually parallel, but they are in parallel. So the way to look at it is to see, so this is the positive side. So let's say all the positive sides, so this is the positive side of the resistor, positive, positive. They all must connect without any disruption. So they don't have any other resistance or other resistors, any other batteries where I drew this pink line. And also on the other side, on the negative side, they must connect without any other resistors or switches or batteries of any kind. See the green line? It's nicely connecting one resistor to another. If you can do that, then they are in parallel. So the difference between series and parallel is that when we are looking at the V total, they all get the same V total. So this is V total, V total, and V total. But what is different is the current. So if you look at the current, so let's say we have I1 here. You see that here there's a branch. So water flowing through a branch is like current. So we have here R1, let's say this is I total. R1 gets I1, and then it branches again here at this location. So R2 gets I2, and then R3 gets I3. So I total, which is the current that goes through the battery, is equal to I1 plus I2 plus I3. So let's say I total had 5 amps. So if this had 5 amps, then I1, I2, and I3, when you add the 3 together, it must equal to 5 ohms. So how do we find the equivalent resistance here? Req. We actually have to do the reciprocal. So what we need to do is to 1 over Req equals 1 over R1 plus 1 over R2 plus 1 over R3. And that's how we find the equivalent resistance in a resistors in parallel circuit. Now let's look at something called the Ohm's law. This says V is equal to I times R. So V here is voltage in volts, I is current, is in amps, and R is the resistance, and that is in ohms. Call it ohms. It has the Greek letter omega. So the units of resistance is ohms.